Arun sir, you can start the session, sir.
Thank you, ma'am. Thank you, ma'am. Hello, everyone. Good morning.
So you didn't keep mic.
Yes. Thank you. Sorry. All right. Yeah, I've sent a problem, students. Look at the problem. All right. So I've got a disk of radius capital R. This is R by 2. This is R by 2. I cut a disk of radius R by 2 with radius as diameter passing through center and the periphery. I've cut this and placed it on this right side. I have to find the center of mass of this system, of this planar body. So what do I do? Let us say I fill this with, let's say this sigma. All right, he has given this density, right? He has said uniform disk radius R. So let us say that is sigma. So this will be, I can fill this with sigma and minus sigma. All right, we talked about this technique last time. When I fill this with sigma and minus sigma, it is same as doing nothing. So when I have sigma, I'll have a complete disk. When I have minus sigma, I have a negative mass disk at this position. So center of mass would be, let's say 1, 2, and 3. 1, 2, and 3. So x naught is equal to m1 into 0 plus m2 into minus r by 2 plus m3 into r by 2 by m1 plus m2 plus m3. Right? Is it okay? m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3 sigma m. All right. Sigma mi xi by sigma m. Okay, now what do we get? All right, mass M1. So X naught is equal to how much is M1? Sigma into pi r square into 0. Anyway, 0 is gone. Plus M2 is negative sigma. So minus sigma into pi r by 2 square into minus r by 2. Plus M3. M3 is plus sigma. Sigma into pi r by 2 square into r by 2 by M1 plus M2 plus M3. So I'll have sigma into pi r square minus sigma into pi r by 2 square plus sigma into pi r by 2 whole square. Sorry, pi r by 2 square. So this anyway gets cancelled out. And sigma pi r square, right? Is sigma pi r square. And what about this one? This negative into negative becomes positive. So this is twice of this one. So I can remove this 2 and remove this 1. I'm just simplifying it further, okay? This fix of the problem is done. Remaining is just simple math, algebra. Sigma gets cancelled out, pi gets cancelled out, 1 r square gets cancelled out. So I'll have result to be x naught is equal to, is anyway gone. So sigma pi gets cancelled out, r square gets cancelled out. So I'll have r by 4. Let me check the answer. Yeah, r by 4, that's right. Check if it is correct. From here to here, is it correct? Students, we're going to do problems today, all right? So that you're comfortable in calculating center of mass. Check if this is correct. From here to here, is it correct? X is equal to r by 4. Have you understood what I've done here? I've added sigma and minus sigma. I've added a disk of density sigma and I've added a disk of density minus sigma. So in effect, I've added nothing. All right, that's a hypothetical step. We don't have negative mass over here, but we have just said that if I add plus sigma and minus sigma, plus m and minus m over there, this is nothing, 0. Because of plus sigma, I'll have a whole disk. Because of minus sigma, I'll have a smaller disk. All right. Answer is right, but I'm just telling you if this my simplification have you understood or not? All right. I'll send another question. All right. Look at the first question is very simple. So quickly answer the first question. Then we'll go ahead with evaluation of center of mass. I mean position of center of mass for the second and third. But look at the first question. It's pretty simple, students. Read the first question. Are you all doing? Are you all reading it? Who all we have here? Hashini, Vignesh, Bhavna, Shivani, Rikita, two more. Six, seven. Yeah, I'm waiting for your answer. Are you all reading?
Yes.
Okay. Others?
Yes, sir.
Okay. Okay. Okay, Shivani. All right. So let's go ahead with the solution. So you got a uniform square plate and some identical squares at the corners are being removed. Where is the center of mass of the uncut plate? By symmetry, it's at center. All right. Of the uncut plate, by symmetry, it should be at center. You will see uniform plate. When I remove one part, let's say part one, when I remove one part, it moves in the other direction, opposite direction, diagonally opposite to the removed part. Let's say I remove this part, my center of mass moves towards right. So this part is removed. If this part is removed, my center of mass moves diagonally towards downward towards bottom left corner. Center of mass was at center when the piece was here. When I remove this piece, center of mass moves in this direction. It moves towards 3, right? Where does the center of mass lie? After squares 1 and 2 are removed. After 1 and 2 are removed, 2 is also removed. If this is also removed by symmetry again, this will lie along this line, shifted downward. Now, if only 1 and 3 are removed, see this logical conclusions are important by symmetry. Already, you'll have questions mostly based on symmetry itself. And so, see, ultimately, you should be able to crack problems in exam. So those tricks and techniques you have to learn here, practice here, so that in exam you don't waste time. You save time. If 1 and 3 are removed, by symmetry again, it lie along this line and this line. It lie at center. If 1, 2, and 3 are removed, in this case, it will again lie along the line of symmetry and shift it towards right, bottom right, like this. Now, when all the 4 squares are removed, what happens? If I remove all the 4 squares, again by symmetry, it will lie at the center. So here we did not evaluate the exact position of center of mass, but we could conclude the region in which the center of mass is lying, direction in which the center of mass is moving if I remove a part. All right, is that okay? Say something, yeah. Okay, look at the second one. I've got a L-shaped rod of mass m, and a particle of mass m is attached at the end of the rod. Find the center of mass of the system. Okay, answer is also given over there. All right. When I have a rod of mass m, this is m by 2. This is m by 2. Agree with that? This is O, y-axis, x-axis. Now there is another particle of mass m attached here to the end of the rod. So center of mass of this one, I can treat this as one body, one figure, one rod, the other rod, and the particle. So I've got 3 bodies now, 3 segments. So I'll have m1. Let's say this is 1, 2, and 3. So x0 is equal to m1 x1, which is 0, because center of mass of this is lying on this line, this itself over here. So its coordinate is 0, plus m2 into L by, if this total length is L, this is L by 2 and L by 2. So this will be L by 4. L by 4 plus m3 into L. Sorry, L by 2. Because m3 is at a distance of L by 2 from origin by total mass, 2m. This will be gone. So M2 is how much? M by 2. M3 is M. So M gets cancelled out. Simplify this and tell me what's the answer. I get the x coordinate out of this. Similarly for y coordinate. You tell me the answer for x coordinate. Students, are you all there? All I'm asking you is to simplify this. M gets cancelled out. So I'll have L by 8 plus L by 2 by 2. Hmm. Is it correct? I doubt this is correct or not. Please check.
Yes,
This
sir.
is correct.
Yes, sir.
Is it correct?
Yes, sir.
Okay. So what is the final answer? Oh, this length is L. Yeah, this is not length. You're not saying anything. This length is L, not L by 4. This is L. So this will be L by 2. This is L. So this will be L. So M by 2 by M by 2 times, sorry, L by 4 plus L by 2.
So 5L by 8.
Sorry, 5L by
8.
okay. Yeah, that's right. Now let's see the y coordinate. Y naught is equal to 1 into M1 into L by 2, which is M by 2 into L by 2 plus M by 2 times 0, because y coordinate of this is 0, plus y coordinate of this is also 0, by total mass is 2m. So this is anyway 0, 0 is gone. M is getting cancelled out. So I'll have L by 8. So my coordinate is 5 by 8 comma. My point C, center of mass, is at point 5L by 8 comma L by 8. Hope that is clear. Okay. So let's go for the next one, third one. Quick, there are some more problems to be done, students. Look at the third one. Third one is a nice one, interesting one. I mean, relatively interesting one. I've got a semicircular ring, origin, at a distance x. I've kept a mass, particle of mass m or 2m, m. Mass of the ring is 2m. Mass of the particle is m. I have to find x such that center of mass lies at origin. So if this is 1, this is 2, x naught is equal to m1 x1 plus m2 x2 by m1 plus m2. Now this should be equal to 0. That's it. Y coordinate is anyway 0. If I take my x coordinate to be x-axis to be along this line, my x-axis x coordinate should also be 0. That's what he says. It should lie at origin. Y coordinate is anyway 0 by symmetry because it lies along the line of symmetry. So tell me one thing, where is the center of mass of a semicircular ring? We have done it yesterday. What is the value of center of mass of the ring? Semicircular ring. Where does the center of mass lie? It lies at 2r by pi from center. So this radius is r. This lies at 2r by pi. So I have 2m into minus 2r by pi plus m into x required by 3m equal to 0. 3m goes to the right, useless, very useful. And then m gets cancelled out. I mean, if I take m common, send it to the right, it's gone. So I'll have minus 4r by pi plus x equal to 0. Implies x is equal to 4r by pi. Okay, let's go for the next one. Hope that is clear. Yes, friends, I've sent one more set of questions. All right, before solving the, okay, let's go ahead. Let's go ahead. Uh, so what's the next question? I've got a planar figure. I'll just tell you how to do this one. Okay, because there's something else I've got to do. I've got a 4 centimeter, out of which I remove the 2 centimeter part from here. So I'll section this into square, square here, rectangle here, and rectangle here. I know the center of mass of this one, center of mass of this one, center of mass of this one, center of mass of this one. I'll write m1 x1 plus m2 x2 plus m3 x3 plus m4 x4 by. That's one way of doing it. Or I'll fill with this sigma and minus sigma. Alright, that is better. Either I can section this into four rectangles, four quadrators, and find the center of mass, or I can fill this with sigma and minus sigma. I'll get a square of sigma, I mean bigger square with sigma, and a smaller square of minus sigma. All right, you try this second method, you'll get an answer very quickly. All right, let's go for another one. See, let's say I've got a disk. Instead of a ring, I've got a disk now. I have to find the center of mass of a disk. What I do, at a distance x of radius x, I take an arc of width dx. All right, so radius r, sigma naught, I have to find center of mass of this one. So what I do, what is it? Whenever you have a continuous mass distribution, what is the formula? It is integral x dm by integral dm is my position of center of mass, where x is position of center of mass of the dm element, the infinitesimal element. So my infinitesimal element is a ring here. For a ring, I know what is x. What is x for a ring? What is the position of center of mass of a ring? 2r by pi, 2x by pi times dm. What is the area of this one? Area of the ring, thin ring of width dx, pi r into dx. That's the area. Mass would be into sigma. I got dm. Integral x dm by integral dm. What is integral dm? Total mass. Sigma into pi r square by 2. Now, what are the limits? I told you, we need limits ranging from, it should cover my whole of my matter. My matter goes from 0 to r. So, limits go from 0 to r naught. Now, this is my position of center of mass. Now, why do I take only one coordinate? Because by symmetry, I know that my center of mass lies along this line. So, if I take this as my x-axis, or axis symmetry, my center of mass lies along that line. I will just find that position, because y coordinate is anyway 0. If I take this as y-axis, or z-axis and y-axis, the z coordinate is anyway 0. I'll get the y coordinate as like this. So, can you solve this further and tell me what's the answer? Sigma gets cancelled out. Have you understood this? Students, are you all following, or I'm just speaking? అర్థమైందా ఇది అందరికి?
It, it, it,
Okay. So how do you evaluate this? Sigma gets cancelled out, phi gets cancelled out, 1r gets cancelled out, Integrate this and tell me what is integral x dx? X square by 2. X square by 2 would be under limit 0 to r. So 4 by pi x square by 2 under limit 0 to r by r. So I'll have 4r by pi. Check if it's correct. Yeah, that's correct. All right. So let's go for the next one. Look at the sixth problem in this set, which is in the pick, second pick. Sixth problem. How do we do that? Plus sigma and minus sigma. All right, that mathematical artifact. Read the sixth question. Determine the coordinate of the center of mass of a thin homogeneous plate having the form of a rectangle with side r and 2r, from which a semicircular portion with a radius r is cut out. For a semicircular disk, it is 4r by pi. For a ring, it is 2r by pi. So this is the remaining portion. So what I do, let's say that sigma, I fill this with sigma and minus sigma. So when I fill it with sigma, I get a complete plate whose center of mass is a distance of r by 2. I'll take this as origin. What is the origin he has given? Okay, he has already given the origin. And by symmetry, it will lie along this axis. I don't have to worry about y coordinate because it's anyway 0. So x coordinate will be x naught is equal to sigma into or m1 into r by 2 plus m2 into 4r by pi by m1 plus m2. What is m1? Sigma into 2r square into r by 2 plus, no, negative sigma, minus sigma pi r square by 2 into 4r by pi by total masses sigma naught into 2r
Sir,
square minus pi r square by 2.
sir, sir,
Simplify this further. Okay, handwriting is really bad. Sorry, I write it properly. Sigma naught times 2r square into r by 2 minus sigma naught times pi r square by 2 times 4r by pi by sigma naught times 2r square minus sigma naught times pi r square by 2. Now simplify this and tell me the answer. Simplify, students, quick. So what's the answer? I mean, answer is anyway there in the pic, but can you tell me what's the simplification over here? I'll cancel out 2 here, cancel out sigma, I'll cancel out pi, and cancel out 1 r square. Yeah. So minus r by 4 minus pi. So minus 2r by 4 minus pi. Is that the answer? Check. Check if that is the answer. Is it correct? Or if not correct, we have to do it again. See, this is a mains level and Neet level problem. Any cavity you have got, you fill it with sigma and minus sigma. All right. If at all you have a volume mass density rho, fill it with rho and minus rho. All right. Please check the answer.
No, sir, it's wrong.
Sorry,
It's wrong.
your voice is not audible, Vignesh. I mean, you're unmuting and muting immediately, so I think the voice is cut.
It, it's so
Okay, anyway, I'll check. Yeah, that's right, no? I'll check the answer at the end. Concept solution one. Friends, we've done a mistake in the last question. That's why we are not getting it right. The center of mass of this semicircular disk is not 4r by pi, it is 4r by 3 pi. All right. It's there we have gone wrong. And you people are not talking at all. Don't know why. If you're not able to understand, let's stop the class, students. Or you ask something, you stop me and ask, or do something, but speak something. If you're not understanding what I'm speaking, why do I conduct the class? All right. I mean, we'll look for an alternative. We'll look for a solution. So center of mass is 4r by 3 pi. So I'll have sigma into 2r square into r by 2 minus sigma into pi r square by 2 into 4r by 3 pi by sigma into 2r square minus sigma into pi r square by 2. Now simplify this and tell me what's the answer. Quick. We also have got two more questions to be done. All right, I'll leave these questions to you. I'll go ahead with the other derivation. Okay, I've sent a pic. Those values you have to remember. All right. I usually forget the digit over there. Sometimes I make it T3 or 2 or 1. But you have to remember because exam is, you are going to write the exam ultimately. So these values you have to remember. For a hemispherical shell, it's r by 2. For a solid sphere, solid hemisphere, it's 3r by 8. For a cone, it's h by 4, irrespective of radius r. For a solid cone. For a thin cone, shell, conical shell, hollow cone, it's h by 3. All right. You try to derive these as well. All right. We don't have time to derive. They are very simple. All you have to take is just an element. Take an element. The way we have done in integration classes, take an element, write integral x dm by integral dm, where x is the position of center of mass of that element. All right. So first derive shell, then go for solid sphere. Cone and hollow cone are easy. You will face difficulty in deriving shell. Okay, anyways, let's go for the next one. And these values you have to remember, students. I'll ask you tomorrow. I mean, when we apply for problems, like when we come across problems on these cases, you have to remember these values so that we can go ahead faster. All right, look at the seventh question. Look at the seventh question. Center of mass will obviously lie along the diagonal by symmetry. So if I just talk about x coordinate of center of mass, y coordinate of center of mass will be exactly the same thing. If I take x and y axis along the diagonals, I mean, if I take x and y axis along the sides, such that line of symmetry is y is equal to x. So how do we do that? Seventh one, how do we do? So Bhavna, Bhashini, Vignesh, Shivani, Gayatri, Vikita. So how do we do this? How do we do this seventh problem? Now center of mass should lie at point A, where A is this point A. I'll tell you how to do. And this is AL. All right. Now look at this. I fill this with sigma and minus sigma. Let this be sigma. I'll fill this with sigma and minus sigma. So effectively, there's nothing. So I fill this with sigma and minus sigma like this. So I'll have, so what I do, he has given the axis, but I can also take the axis to be like this. Ultimately, he wants A, right? So I don't have to worry about the axis. No matter what the axis is, my solution has to be same. So I can take this as axis. I'll tell you what to do with this as axis. But because my line of symmetry is this one, I'll take this to be x-axis. I'll take this to be y-axis. He's asking ratio A by L. So if I find out A by L, I'm done. So whether the axes are like this or I like this along the edges or along the diagonal, it doesn't matter. Answer will not depend on the coordinate axis. All right. Now, center of mass of that sigma, big square plate is at center. Center of mass of the small negative mass square plate is at center of this one, which is a distance of A by 2 from here. So what is this distance? This distance would be L by root 2 minus A by root 2. So my center of mass would be sigma times L square into 0 minus sigma times A square into L by root 2 minus A by root 2 by sigma times L square minus sigma times A square. Sigma is cancelled out. Now this should be equal to L by root 2 minus A root 2. Think why? Think why? Why should it be L by root 2 minus A by A root 2? He says this should be the coordinate of the center of mass. That means this is L by root 2. This is L by root, right? This is L root 2, L by root 2. L by root 2 minus A root 2 is the coordinate of the center of mass. I mean, coordinate of point A. X coordinate of point A. I've done it using x-axis to be diagonal and y-axis to be other diagonal. You try it with x and y-axis to be like this. You'll get the same answer. All right. So I hope you understand this equation. This equation is done. If this is solved, you get the A by L. That's it. So this is gone. Okay, I'll do it again. L by root 2 minus A root 2 is equal to, this is gone, and this will be negative minus sigma a square L by root 2 minus a by root 2 by a square minus L square into sigma. So sigma is gone. Root 2, this becomes L into L minus 2a by root 2. This root 2 and this root 2 are gone. A minus L and L minus A. Alright, so I'll write it as 2a minus L here is equal to a minus L. I'm just simplifying. I'm doing maths. Alright, nothing more than that. If this is a minus L, this is a plus L. So a plus L into a minus L. A minus L is cancelled out. What I'll get is a plus L here. Cross multiply 2a square I want a by L, right? I'll take a common. Sorry, L common from here. Solve for x. You people are not listening, so I'm going faster. You're not people are not responding at all. I don't know why. What happened to you? Like usually you're not responding in the morning, or you're not able to understand my class, or like what's your problem? If you don't have got any problem, please let us know. We'll solve it out. We'll sort it out. All right. Try this one. Think about it again. Answer is there in the solution. Answer is there in the answer section in the pic, and that's right. You try this with x and y axis to be like this, x axis to be like this, y axis to be like this. X axis to be along one edge, perpendicular to that edge is y axis. All right. All right. Thank you all students. Have a great day. Bye everyone.
Thank you, sir. Students, you can join in next session.